Hey y'all, in this video lesson, you're going to learn how to solve right triangles using the basic trig functions. We've learned a couple of tools already to solve some right triangles like the Pythagorean theorem and special right triangles, which were the 45, 45, 90 and the 30, 60, 90. So these scenarios we're going to look at today are scenarios where those two tools or three tools don't apply. And we're going to use the basic trig functions to help us find the missing pieces of a triangle. So we had a scenario in a previous lesson where we were building a ramp for skateboarding and we were given some information. So let's draw this triangle out or this ramp out and use some of our new information to solve. So the ramp was 3 feet high. It was an 11-degree angle from the ground. And we want to know how long the the ramp should be. So this is a right angle here, which means we can use our trig functions. And if I'm focusing on this angle, so from this angle that we're focusing on, we can label the sides of our triangle to help us figure out which trig function we want to use. We've got obviously the hypotenuse, and then across from angle measure, we'll just call it theta. Theta is opposite, that's 3, and then that's all we were given. So based on what we were given, we can pick the correct trig function to use to solve for the hypotenuse. Now, if we were given this side, we could just use the two sides and find it, but we weren't. So if we have SOHCAHTOA, and we were given opposite and hypotenuse, then we're going to use sine. So I can say sine theta equals opposite over hypotenuse. And in this specific case, theta is 11, opposite is 3, and we're solving for the hypotenuse. We're going to have to do a little bit of algebra to manipulate this equation to solve for x. I'm going to multiply both sides by x so that the x's over here divide. And now we have x sine 11 equals 3. And then now I'm going to divide by sine 11 on both sides. And this is the exact solution. And then we're going to find an approximate solution by typing that into your calculator. Before you type it into your calculator, make sure that you are in degree mode. So it's degree mode because we're talking about degrees, 11 degrees. So I'm going to pull up the calculator here, and I'm going to show you how to do that in a TI 83 or 4. You're going to go to mode, which is at the top. And then you're going to go down to, let's see, where is it? Mine's way down kind of in the middle. Right now I have it in radian mode. I'm going to click degree and then done. On your calculator, if you have a handheld calculator, you might have to do a second mode, which is quit to get out of there. And now I'm in degree mode. So I'm going to type in 3 divided by sine 11. And I get about 15.72. So since I've found the approximate solution for the hypotenuse, I can now find the other missing side. So if you're solving a right triangle, or if you're solving a triangle, then you're trying to find every missing piece. So that means that now we need to find this third side, and we can use the Pythagorean theorem for that, or we can use another trig function, whatever you prefer, doesn't matter. And then we need to find this third angle. The third angle is going to be really simple to do. We already have 2 angles, and the 3 add up to 180. So just do a little subtraction there. And then you can use Pythagorean theorem or trig functions to find the missing side. So go ahead and pause it, try to finish it, and come back and check your work. Okay, so for the missing angle, you should have gotten 79 degrees. And then with that angle, you can use tangent to find the missing side, which you'll see on the bottom line of the calculator, or you can use the Pythagorean theorem with the sides that you do know. You'll see on my paper that I used the exact solution in the Pythagorean theorem here. I was nervous about rounding issues, so I used exact right there. But you can see in the calculator that I did go ahead and use the rounded solution from up here, and I still got the same answer. So as long as you round to several decimal places, you should be pretty close. But if you're super paranoid like I am, then you can just go ahead and use the exact solution there, and then make sure you take the square root as your last step, and you get 15.43 feet for the third missing side. Yeah, the third side. So that's how you solve that right triangle. Now for the next one, we have, again, two missing sides. In this case, we were given the hypotenuse, and then we were given two angles. So I want you to go ahead and pause it, try it, come back, and check your work. Okay, so hopefully for side, or sorry, back up. Before you start, it can be helpful to go ahead and label your triangle. So based on the angle that we were given, 32 degrees, from 32 degrees, side B is opposite, side A is adjacent. And then with that, you can figure out which trig functions you want to use to solve. So if we're solving for B, we're going to use sine because that's opposite over hypotenuse, and then multiply both sides by 11. That gives you B. 11 sine 32 would be the exact solution. So if it's asking for an exact solution, 11 sine 32 is that. If it's asking for an approximate solution or rounded solution, then 5.83 would be 2 decimal places. And then for side A is adjacent to 32, so we would use cosine. Cosine 32 equals A over 11, multiply both sides by 11. 11 cosine 32 would be the exact solution, rounded would be 9.33. And we could have found that third side by using the Pythagorean theorem instead, but I just wanted to practice using trig functions. So in either case, as long as you got 5.83 and 9.33, you're good to go. And then the last angle is simple addition subtraction. You should get 58 degrees right there. So that triangle is solved. Let's take a look at this example right here. In some cases, we have all three sides of the triangle and we're missing two angles instead. So I have an example here. I don't have it labeled, but this is a right triangle and I'm given three sides. So can't really use subtraction to help me find the missing two sides. I'm going to have to use trig functions. And what we're going to use in this case is inverse trig functions. Inverse. So if I'm focusing on angle C, then I could use sine C. You can pick a different one. You could do cosine or something like that. But I'm going to use sine C just for the example equals opposite over hypotenuse. And I'm looking for C. And what we use here is called inverse sine. And it looks like sine raised to the -1 power. An inverse sine is going to basically undo sine. So in solving linear equations, if you remember, if you had 2 times x, to undo it, you would divide. So this is very similar to that. To undo sine, we're going to do inverse sine, and we'll do that to both sides. Then also make sure you're in degree mode because we are talking about degrees. We will cover radians later in later videos, but for now we're looking at degrees because we're talking about this triangle here. So you would do inverse sine, whoops, misspelled that, inverse sine of 3.2 over 4.6. And you would just type it in like that, and you would get an approximated solution for C. So basically what's happening here is we're taking the inverse, I did it again, sine of sine, and then I ran out of room here, sorry. And these inverses like undo each other. So we end up with C equals inverse sine of the ratio. Okay, I want you to use that to find the two missing angles, sorry. Pause it, find the two angles, come back. Okay, so for angle C, if you were to type that in, you're going to do second sine to grab that inverse function. And we have 3.2 over 4.6. Whoops. And we get about 44.08. And then for the last angle, you can just do 180 minus 44.08 plus the 90-degree angle. Or you can use cosine in those same two sides to get 45.92 for the missing angle. Yes, that's it. So inverse sine will help you find a missing angle. And that is not inverse sine, inverse trig functions will help you find the missing angle. Sorry about that. All right, that's all I have for this lesson. I hope you enjoyed it. If you have any questions, please let me know. I'd be happy to help, and I'll see you in the next one.